Hello everyone, welcome to my channel. In this video, we are going to break down the UGC NET Computer Science previous paper of the year June 2008 paper 2. There are actually 50 questions and we'll cover the first 25 questions in the part 1 and the remaining 25 in part 2. I will explain complex concepts in simple terms and provide tips and tricks to help you ace the exam. So, whether you are a beginner or an experienced one, this video is for you. So let's start the video. Which of the following doesn't define a tree? So from the given options, which one doesn't define the tree? So in order to solve this question, we must know what is meant by a tree. So what is the definition of a tree? So tree is also a graph without any cycles. Right? Tree is an undirected graph without a cycle. In a graph, it will form from the vertices will be connected with the remaining vertices and it will form a cycle. But in the tree, it doesn't form a cycle. So we'll take each and every option here and we have to find out that which option doesn't define the tree. A tree is a connected acyclic graph. So it is correct, right? So tree is a connected. That means every component will be connected with each other. And acyclic graph. Acyclic means so it won't form any cycles. Right? A tree is a connected graph with n-1 edges where n is the number of vertices in the graph. So a tree is called as a connected graph. So that means every component is connected with each other. Suppose there are n vertices, then there are n-1 number of edges. Suppose in the given tree, so if you consider there are 7 vertices. So 7 vertices are there and edges. How many edges are there? 6 edges. So 7 vertices and 6 edges are there. Okay. So that means the vertices must be, so here the n is the number of vertices and n-1 number of edges. That means the edges are 7 vertices minus 1. So this property is also satisfied. So B is also correct one. Next. A tree is an acyclic graph with n-1 edges where n is the number of vertices in the graph. A tree is an acyclic graph. It is the correct one, right? With n-1 number of edges. So we have n-1 number of edges where n is the number of vertices in the graph. So this one is also correct. Next. A tree is a graph with no cycles. So a tree is a graph, but it is a connected graph. So option D cannot be true. Since if graph is not connected, then it cannot be a tree. So a tree is a connected and undirected graph with no cycles. So option D is the correct answer. So it doesn't define the tree. Next. The complexity of Kruskal's minimum spanning tree algorithm on a graph with n nodes and e edges is. So we know that Prim's algorithm and Kruskal's algorithm are minimum spanning tree algorithms. So in this algorithm, it will find an edge of the least possible weight that connects any two trees in the forest. So suppose there are e number of edges in the graph and if there are e number of edges in the graph and n number of vertices, so e number of edges and n number of vertices in the graph, then Kruskal's algorithm will run big O of e log n time. So using array simple data structure. So answer is option C, e log n. Next. If a code is T error correcting code, the minimum Hamming distance is equal to. If two code words are Hamming distance D apart, it will take D 1-bit errors to convert one into the other. So normally for detecting an error, it needs T amount of, the minimum distance will be T. So if suppose if it is error correcting, then it is 2t plus 1. So answer is 2t plus 1 is the correct one. The set of positive integers under the operation of ordinary multiplication is. So here the set of positive integers with ordinary multiplication forms a semi-group. So it forms a semi-group which may be designed as z plus comma dot. The product of any two positive integers is a positive integer and hence it is associative. So the product of any two positive integers is a positive integer and hence it is a associative. For example, I am considering a number 2 into 3 into 5. If suppose, and that means it is equal to 30, right? If suppose it is a following a commutative monoid under multiplication, then 2 into 3 into 5. Right? The answer for this one is also 30. Okay. So that's why the answer cannot be a group. B, not a group, since it is following the commutative law. So this question is following the pigeonhole principle. So in the pigeonhole principle, there are n number of pigeons and m number of pigeonholes. So here the condition is, so n is the number of pigeons and m is the number of pigeonholes. And here the condition is that so n must be always greater than m. So if n is greater than m, that means if the number of pigeons are more than the pigeonholes, then there must be at least one hole with two pigeons, right? Okay, so this given question is also following the same rule. So we can solve this by the same rule. In a set of 8 positive integers, there are given 8 positive integers here, and there always exists a pair of numbers having the same remainder. So in the 8 numbers, we have the pair of numbers with the same remainder. So which is divided by the following numbers. So using the pigeonhole principle in set of 8 integers, in worst case, 7 will have at least one pair with the same remainder. So from the given question, n is 8 here and m is, so m must be the given option. Okay, and n must be greater than m. So from the given options, if you check, so n is greater than m. So m, suppose m value is 7, so 8 greater than 7 is satisfied. If suppose m is 11, then 8 greater than 11, so it is not satisfying, right? 8 greater than 11 is not satisfying. And greater than 13, 8 greater than 13, so it is also false. 8 greater than 15, it is also false. Okay, so by the pigeonhole principle, so 8 greater than 7 is correct. Okay, and how to find out that? So there are at least two pair of numbers. There exists a pair of numbers from the given 8 positive integers with the same remainder. So for this we have the function ceil of n by m. So ceil of n by m. So n is 8 and m is 7. So we will get the ceil of 8 by 7. So we will get 1 point something answer, right? So 1 point, so 1.11 like that. And ceil means it will round up the value. So that is a 2. So answer is 2. So at least there must be a pair of numbers with the same remainder. So option A is the correct answer by pigeonhole principle. Next. An example of a tautology is. So given options, we have to find out the example of tautology. So what is meant by tautology? If the condition in the given truth table, if all the statements follow the true, then it is called as a tautology. And suppose if all the statements follow false, then it is a contradiction. Right? In logic, tautology is a formula that is true for every possible interpretation. Okay. So here x or negation x, so which is always true. So that's why The answer is option C. Suppose if you are taking x as true, so true or negation, true means false. So true or false means true. So it is always true. So example of tautology is option C. Among the logical families, RTL, TTL, ECL and CMOS, the fastest family is ECL because ECL is the fastest of all the logical families because the propagation delay is very small. So here you can observe in the table, the propagation delay of ECL is very small compared to the remaining logical groups. So that's why ECL is the correct answer. So this is the fastest of all the logical groups. The octal equivalent of the hexadecimal number FF is. So here given the hexadecimal number FF, we need to find out the octal equivalent here. So first of all, we have to convert the given hexadecimal number FF into binary value, and then we have to convert that binary value into octal equivalent. So we'll see the process here. So first of all, so F in hexadecimal is denoted as 41. Hexadecimal is denoted as a 4-bit binary number because hexa means here hexadecimal means 16, right? That means 2 power 4. So the binary equivalent is a 4-bit. So since there are 2 F's, so we will write 2 times the 4-bit binary sum. So FF base 16 equals to this 81, consecutive 81. Next, so we have the binary number available here. We have to convert the given binary number into octal equivalent. And we know that octal equivalent is octal means 2 cubes, right? So 2 cubes means we will consider only 3 bits from right to left. So group of 3 bits from right to left. So here, so if you consider the group of 3 bits here from the right to left, so 111, and there are 2 ones remaining. So you will add 0 for completeness here. You will add a 0 for completeness. So now, so if you write the value here, 011 means 3, 111 means 7, 7. So 377 is the octal equivalent of the given hexadecimal number. The characteristic equation of a T flip-flop is given by. So from the excitation table, if you know the excitation table of the T flip-flop, then we can write the characteristic equation of the T flip-flop. The characteristic equation is TQN dash plus T dash QN. Since it is a toggle, right? So whatever the input that we are giving to the logical gate, it will toggle the output. So T XOR QN is the answer. So T dash QN plus T QN dash. That is the T XOR QN. So option C is the correct answer. Next. What is the effect of the following C code? So int I equals to 1, I less than 5, I equals to I plus 1 by 2. So from the given code, for int I equals to 1, I less than 5, I equals to I plus 1 by 2. That means here I is initialized as integer value and the for loop executes here and prints the value. So we must find out the option that what is the output of the given code. So if you observe, I is initialized as an integer here, right? It is initialized as an integer. Now if we add the I value with 1 by 2, so that means 1 by 2 means it is also integer only, right? So 1 plus 1 by 2 means 0.5. That means 1.5. But here 1.5 is a float value. 1.5 is a float value. And here I is defined as an integer value. So now it will convert the 1.5 to 1. So I will be 1 only. Okay. So here I equals to 1 less than 5. Okay. And it will print the 1 value first of all. Then it will increment the I value by 1 by 2. But the I value won't change here. It will be 1 only. So again the loop will repeat and again I equals to 1. So I less than 5. So I equals to I plus 1 by 2. So I plus 1 by 2, that is 1 plus 0.5, and again it will be converted to 1 value. So like that this for loop will repeat forever and it will print all ones only, because so every time when the for loop is executing here, the I value is again becoming 1 only, it is not incrementing here. So that's why option D is the correct option. It prints 111 and repeats forever. So consider the following declaration in C language. Character A, that is the array of characters, and a pointer P, which is initialized as a character. So we have a array of characters here and a pointer pointing to this array of characters. So both are initialized as a character value. Okay. So this is the array A. So from the given statement, it is a not valid statement. So P equals to A. So it is correct only, right? So here the pointer P address is the first location of the array. That is the base address of the array. So the pointer P equals to A is a valid one only. Next, P equals to A plus 2. So when the pointer increments here, here P is pointing to the base address of A, that is A of 0. Okay. If you want to point to the second address location in the given array, then you can refer it as a P equals to A plus 2, which is a valid one. And A equals to P is not valid, because it is changing the base address of the array, so which is a invalid one. So option C is not valid, and option D is also correct. So we are P equals to address of A of 2. So we are pointing to the address of second location here. So it is pointing to first location 1, 2. So if it is pointing to the second location, then P equals to address of A of 2. Okay. So this is also valid one. So option C is the correct answer, which is a invalid address and invalid, and it is changing the base address of the array. Option C is the correct answer. Next, consider the following C code: int A equals to 5, B equals to 9, and float R equals to B by A. So what is the value of R? So here A and B are initialized as integer values and R is initialized as a float value. So here there is a type conversion, right? So first of all, R equals to B by A, that is 9 by 5. Okay. So 9 by 5. So here R equals to 9 by 5, that is 1.8. But here B and A values are in integer type. So that's why this division will give only 1, since it is 1.8, but the A and B values are integer, right? So now this 1.8 will be truncated here and it will become 1. So it will give only 1. Okay. So 9 by 5 is 1. Now what will happen here? Float R and R equals to B by A. So given it is the R equals to B by A. That means, so we are converting the integer value into float value. So now, so if you convert the given integer value 1 into float value, then it will become 1.0. Okay. So the answer is option B, 1.0. Function overloading is a concept in which of the options will follow. So let us evaluate each option here. So first one is, a function is used to implement lots of tasks at the same time. So this option is not correct. Function overloading refers to defining multiple functions with the same name but different parameter lists. So not performing multiple tasks simultaneously. Suppose if you want to perform, if you want to find out the area of a rectangle. Okay. So I want to find out the area of a rectangle, of a circle, of a square. So here the parameters will change. For square we need only one parameter, and for rectangle we need two parameters. Like that, here the parameters will change. Okay. So that's why this is wrong. So it lot of tasks, implementing lot of tasks at the same time. Next, option B. A function is called too many number of times by another function. So this one is also incorrect because function overloading is not related to how many times a function is called. Option C. A function provides common interface to the user to carry out possibly different functions in each call. So this is the correct one. Function overloading allows multiple functions with the same name but different parameters to act as a common interface, performing different tasks based on the arguments passed. Suppose you are executing a function area here. So area of a square is only, so we need only one parameter, that is s. So area of a square is s square. Similarly here, area of a rectangle. So suppose I want to know the area of a rectangle, then the parameters are a comma b. That is the length into breadth. Okay. So like that, here the function call is same and the parameters are different here. So option C is the correct answer. And what is the option D here? A function is computationally too expensive for the system to handle. So this is also incorrect because function overloading has nothing to do with the computational expense. So that's why option C is the correct answer. Next. Which of the following is true? Which of the following is true? A static member of a class cannot be inherited by its derived class. So from the given options, option C is the correct answer. Static member of a class can be initialized before an object of that class is created. So what is a static variable first of all? A static variable is a variable that has been allocated statically whose lifetime or extends across the entire running of the program. So when we declare a member of a class as a static member, it means no matter how many objects of the class are created, there is only one copy of the static member. A static member is shared by all the objects of the class. All static data is initialized to 0 when the first object is created. So if no other initializer is present, so option C is the correct answer. A super key for an entity consists of. A super key is a combination of columns that uniquely identifies any row within a relation database management system. A candidate key is a closely related concept where the super key is reduced to the minimal set of columns required to uniquely identify each row. So that's why option D is the correct answer. That is one or more attributes. So normally in primary key, so we are considering only one key as a unique key here. So suppose there is a student table. So the student table ID will act as a primary key because the ID is different for every student. Similarly here, a super key consists of two or more attributes. That means two or more keys. Which of the following set of keywords constitutes a mapping in SQL? So in SQL, query structure is select the attribute. That means it defines the attributes to be selected here. Attributes to be selected from the particular table. And from table, that means it defines the relation on which the query needs to be executed. And where condition. So it specifies the condition according to which the query needs to select the attributes. So the set of keywords that constitutes the mapping in SQL are select from where. So option B is the correct answer. If a relation is in 2NF form, then so what we will consider? So if a relation must be in a second normal form, the relation must be in first normal form. Then it will be considered as a second normal form. Okay. And if the relation must be in second normal form, then the 2NF must be in the partial dependency. Then there should not be any partial dependency. And in third normal form, there should not be any transitive dependencies. Right. So in the second normal form, So it must be, second normal form must be in first normal form, and there should not be any partial dependency. And every non-prime attribute of the table is dependent on the complete candidate key. That means no non-prime attribute is partially dependent on any key. So partially dependent means dependent on a proper subset of the key. So that's why option B is the correct answer. Next, which of the following is true? A relation in 3NF is always in BCNF. Relation in BCNF is always in 3NF. BCNF and 3NF are totally different. Relation in BCNF is in 2NF but not in 3NF. Here option D is the correct answer. So BCNF, boys code normal form, is always in third normal form. So this is the diagram. So BCNF is a slightly stronger version. So this is a stronger version of the third normal form. That is, a relation in BCNF needs to be always in third normal form. So that's why option B is the correct answer. So if we take any other option, these are wrong. So 3NF is always in BCNF. Right? So this is also wrong, right? So BCNF is always 3NF. So BCNF is a part of the 3NF. Next. Consider the query, select student name from student data, where roll number. So given the outer query and inner query here. So in the inner query, select roll number from student marks where SEM1 mark equals to SEM2 mark. So we need to find out the roll number. Select the roll number from the table. From which table we have to select that? From the student marks. Okay. So we need to select the roll number. So where SEM1 marks equals to SEM2 marks. So here the SEM1 and SEM2 marks must be equal. So SEM1 marks is equals to SEM2 marks. So we need to find out the roll numbers of the students, where the SEM1 marks equals to SEM2 marks. And coming to the outer query, select student name from student data, where roll number. So we need to find out the student name here. Okay. So from the roll numbers, we need to find out the student name. From the student data. Okay. So from the student data, we have to find out the student name where the roll number here matches. The student name and student roll number must match here. Let's say S1 equals to S2. So here from the given option, so the option C is the correct answer. So this query will give the names of all students whose marks in SEM1 is equals to SEM2. So we need to find out the student name here, right, for the corresponding roll number. Okay. So it gives the names of all the students whose marks in the SEM1 and SEM2 are equal, and the inner query will select the roll number here. The inner query will select the roll number, and for whom the marks SEM1 equals to SEM2, and the outer query will select the student names here for the corresponding roll number. Option C is the correct answer. Which of the following data structure is most efficient in terms of both space and time to reverse a string of characters? Options are linked list, stack, array, and tree. A stack is most efficient in terms of both space and time to reverse a string of characters. Why? So why it is most preferred? A stack is a basic data structure that can be logically thought of as a linear structure, and stack follows LIFO rule, that is the last in first out rule. So we have only one entry to enter the stack. So from one side only we can push the data element, at the same time we can pop the data elements from the stack at only one end. So stack can reverse a string of characters efficiently than any other data structure. Which of the following? So here let us write each and every option here. Option A is written as this manner. Okay. So in binary search tree, the basic property is the left child must be lesser value and the right child must be greater value. So based on that property, we have inserted the nodes here for the given option. So option A here is written as. Let us check the value 98 here. So 98 is greater than 100, right? So 98 is less than 100. So we will go left side for the 50. So 98 is greater than 50. So we will go to the right side. We will move right side. But 98 is not available here, right? And 98 is greater than 75. That means 98 must be there in the right part of the 75. But after 75, the 60 has came here, right? So that's why option A is the incorrect option. So it is not correct. Next, let us check the option B. The greater value of 100, 120 is greater than 100. Next, 90, which is less than 120. Okay, and so on. This tree will continue. So let us check the key 98 here. So 98 is less than 100. That means so we have to search the for 98 in the left hand side. But in the left hand side there is no tree. So all the nodes will be formed only at the right side. So after 90 here the 95 will come and 98 will come. So which is the incorrect formation here. So 98 must be there available in the left side of the 100. So here it must be available. But here it shouldn't be available. So option B is also not correct. Right. So next let us check the option C. So 200. So based on the option C, we have made the binary search tree here available. Now let us check the key 98 here. So 98 is less than 200. So we'll go left hand side. And 98 is greater than 70. So we'll go to the right hand side. And here 100 is there. So 98 is less than 100. So we will move to the left hand side, that is 95. And 98 is greater than 95. So here 98 is available. So here the sequence of nodes which are correctly showing the 98 is option C. So based on the binary search tree properties, so this tree is satisfying the BST properties. Next question. Which of the following is true for a sorted list with n elements? Searching for a key in a sorted array can be done in big O of log n time using binary search, while linked list takes big O of n using linear search. Binary search doesn't work on linked list efficiently. So that's why option C is the correct answer. Searching for a key in a sorted array can be done in big O of log n time. Files that are related to input-output and are used to model serial input-output devices such as terminals, printers, and networks are called. So character special files are used to model serial input-output devices like terminals, printers, network devices. Whereas, so here the character special files are used to model the serial input-output devices. And these files will transfer the data one character at a time. So that means each character is transferred at a time in a serial manner. So that's why these type of files are suitable for serial communication with the device like keyboards, mouse, and serial ports. In Unix or Linux, these files are found in the dev directory. Okay. So normally in keyboards, if you press a particular key, then that key will be displayed. Suppose you are typing the keys fastly, so whatever the keys that we have typed first, so it will be displayed here. So they will be queued, and each one character at a time will be printed. Not all the characters will be printed, right? So it is an example of serial communication. So why the other options are incorrect? Regular files, these store user data like text files, binary files, and are not used for the input-output device communication. And directories. These are used to organize files, not to interact with I/O devices. And the block special files. These are used for storage devices like hard disk, where data is accessed in fixed size blocks rather than a character string. So that's why option D is the correct answer, character special file. An example of a possible file attribute is. So an example of possible file attribute is option C, that is the archive flag. The archive attribute is used for backup. When a file is created, the archive bit is turned on, and when a program copies the file, the archive bit is turned off. For example, the \m parameter in the xcopy command in Windows turns off the archive attribute. When the file is edited and saved again, the attribute bit is turned on. So option C is the correct one. So these are the first 25 questions in the UGC NET June 2008 question paper. So the remaining questions will be discussed in the next video. Thanks for watching the video.